Inside this top-secret mega-factory, a car like no other is taking shape. Craftsmen hand-build what they consider an automotive work of art. Money is no object. This machine must redefine a billion-dollar brand. Failure, not an option. Japanese marque Lexus sells itself on luxury, marketing its cars as elegant, quiet, high-tech, and efficient. Now, a different kind of car wears the Lexus badge, the LFA. Aggressive, loud, agile. Highest revving V10 engine in a production car. 325 kilometers per hour. A car like nothing Lexus has ever produced before. Lexus is just over 20 years old. The world's largest car maker, Toyota, created the brand to compete with other high-flying luxury marques, Mercedes-Benz, BMW, and Jaguar. It's worked. Lexus is now one of the biggest-selling high-end marques in the United States. But now, Lexus is out to inject more excitement into their brand. Chief Engineer Tanahashi Haruhiko is the man behind this vision.
The LFA has a passion, an emotion that isn't in earlier Lexus cars. We wanted to move the brand in that direction. That's how we made this car.
Tanahashi believes the marque can mean more than just luxury.
I wanted to make a new sports car, one that could stand against the long-established European so-called supercars, Porsche, Ferrari, and Lamborghini, to show that we Japanese could make something like that.
It's a risk. The company haven't made anything like this before. Their reputation depends on its success. Chief Engineer Tanahashi is stepping into the unknown. He must build a car, a team, and a factory from scratch.
Basically, we proceeded at my discretion. And where there weren't any rails, I laid them down.
Finding a factory in Japan isn't hard when you're part of the country's largest company. Toyota is so big, they even have their own city, Toyota City. Of the company's 15 Japanese factories, 10 are found in the city or close by. Among them, the Motomachi assembly plant. The company transformed two unassuming blocks of this megafactory to create the LFA. They then scoured Toyota's 50,000 Japanese workforce to handpick just 175.
All the associates here at the LFA Works feel they are artisans, not just operators.
These artisans are known as takumi, Japanese for craftsmen, a status only conferred on the most highly trained, skilled workers.
Each and every associate at the LFA Works is seeking to achieve perfection, taking this challenge on with a sort of samurai spirit.
Yamanaka Shigeru is manager of the LFA Works. His teamwork credentials come from another time-honored Japanese tradition: baseball.
Before this, I was working as manager of the Toyota Motor Corporation baseball team, which brought people together from lots of different... It was because I could manage that organization that I was made manager here.
To reach their goal, the tight-knit utilize sophisticated tools and materials to build car. The most important of these is carbon fiber composite. Carbon is crucial to the car's performance. It's a material 5 times the strength of steel, yet a quarter lighter. It's the construction material of choice for both Formula One racing cars and the aerospace industry. The company even make their own carbon fiber here on site. Up until now, no television cameras have ever been allowed inside this top-secret facility. First, simple strands of carbon fiber are woven into a pliable cloth using an automated weaving machine. This fabric is then transformed through heat, pressure, polycarbonate resin, and labor-intensive techniques into the car's core known as the tub. The tub is pieced together like a 3D jigsaw. It starts with the construction of the floor. To make it, precisely cut carbon fiber cloth is lifted onto a mold. Next, skilled Takumi smooth the supple fabric over the mold. This one is for the transmission tunnel that will house the drive shaft and exhaust.
In very complex areas like this, the fabric inevitably becomes frayed and not very neat. The associates work with these areas as if working with silk, taking great care every day.
They also wear masks to avoid breathing in the hazardous fibers.
In the beginning, the associates found it very difficult to work this material. It was much easier when they used an iron.
The completed part is grill heated to set its shape. It's then fitted into a template along with 7 other floor parts and inserted into a 1,000-ton press. A glue-like resin is pumped into the template, and the whole section is then baked for 8 hours at 130 degrees Celsius. Under this pressure and heat, the resin sets hard, binding the individual parts together to produce the car's floor panel. Back in 2000, the concept of a world-beating supercar only exists in one man's head.
At the company, I talked to just a small group of people at the top, not expecting anything, and they said, go ahead and try.
With permission to proceed, Tanahashi gathers a team of engineers around him, and they start to make the basic engineering decisions.
In the beginning, we planned to make the body from aluminium.
But Tanahashi is fascinated with the possibilities offered by carbon.
Developing a supercar, a super sports car, carbon fiber was a material I really wanted to try using, if at all possible.
But this wonder material has its drawbacks. It's expensive, and the company has never used it to build any of their cars before. Despite these significant challenges, Tanahashi gets his way.
In 2005, my boss said, why not go for carbon, slapping me on the shoulder. And I made the decision to go for carbon then.
It's a bold step. Everyone involved with this project must master a material they have no experience with at all.
It was the first time the workers had touched carbon, and everything about it was difficult for the workers.
In the state-of-the-art carbon fibre facility, the Takumi are returning from lunch. They vacuum themselves down to remove any foreign particles before entering a highly confidential sealed room. Here, the majority of the tub's central frame is created using the most intricate techniques. In this process, an automated laser cuts out hundreds of individual shapes from carbon fibre cloth that's been pre-impregnated with a sticky resin. Next, Takumi layer the cutouts, up to 20 sheets deep, onto a mould. This one will make the right side panel.
The associate uses a dryer to raise the temperature of the laminate and half melts the resin as he applies it.
The tacky cutouts stick to each other and any gaps are squeezed out using a vacuum bag that forces them together. The shrink-wrapped side panel is then wheeled across the works and loaded into a pressurized oven. Baking overnight at 150 degrees Celsius sets the resin, resulting in a side panel that's both ultra-strong and ultra-light. An aluminium equivalent would be twice as heavy. Weight saving is the holy grail for all auto engineers. Less weight and more power leads to increased acceleration, and speed defines a supercar. The body of the LFA is 65% carbon fibre, helping it accelerate from 0 to 100 kilometers per hour in 3.7 seconds. If made of aluminium, it will be 100 kilograms heavier, like having a sumo wrestler in the passenger seat. As it is, this car weighs just 1,400 kilograms all in. Back at the factory, in a locked room, a bespoke machine creates two crucial parts to complete the tub's construction. The roof rails support the windscreen, as well as protecting the driver if the car rolls over. This custom-built circular loom weaves the carbon rail in 3D. It uses lasers to control the feed of carbon fibre strands onto 144 bobbins. These knit the carbon around a top-secret automated template that's fed through the centre of the loom. This is done twice over to cross-thatch the carbon weave, so giving the rail its strength. The whole mechanism has its own control box, and for good reason.
If something goes wrong, even a little thing, the shape gets distorted immediately, so the operator constantly pays attention to avoid this.
The side rail is heated and impregnated with more resin to complete its metamorphosis from a flexible tube to a rock-hard rail.
You may think that this is quite heavy, but it is only 2 kilograms.
The tub is bonded in another top-secret jig. First, a super-strong adhesive, known as epoxy resin, is applied by robot and hand to each of the parts. The separate parts are transferred to the jig and locked in place. Pop rivets keep the pieces aligned. To cure the epoxy, the jig is pushed into an oven and then baked for 60 minutes at 60 degrees Celsius. The resulting tub is so strong, it acts as both the structural core of the car and as a crush-resistant safety cell should the car crash. The challenge now is for Matsumoto Kengo, chief designer of the LFA, to create a car with a body as technical as it is elegant.
For us, aerodynamics, heat and airflow management should be tangible in the design.
A conventional car cools its engine with forward-mounted radiators that suck cold air through a front grille. Not the LFA. Front space is at a premium, so coolant is pumped from the hot engine to twin radiators mounted behind the car's rear wheels. Matsumoto had to shape the car to funnel cold air to these vital components.
Airflow management is optimally controlled by setting the angle between the door mirror and the cabin. It goes past the cabin and smoothly into the air intake for the rear radiator. This shape is not just for styling. The intake is deliberately formed here, from the base of the glass.
The result is an airflow system capable of cooling the engine even under the most extreme race conditions. It's 8:45 in the morning at the LFA works. The Takumi are warming up for an 8-hour shift ahead. Their first task is to greet the bare cabin as it arrives from its 15-day build in carbon round the corner. In assembly, the cabin will progress through 4 positions: trim, chassis, final, and alignment. $15,000 parts go into making an LFA. The first of these are attached here in trim. Just meters away, other Takumi assemble the drivetrain and suspension. The drivetrain comprises the transmission, torque tube, and last but not least, a 4.8-litre V10. The location of this engine is crucial to the car's entire concept.
I wanted to build the car around the people in it. And for a supercar that puts people first, the optimum place for the engine is front mid.
This front mid location puts the engine between the driver and the car's front wheels. With the transmission placed at the rear, the driver is in the center and the car feels balanced to drive. The aim is to make the car's handling as good as possible. But a front mid configuration dramatically restricts the space available for the engine. Tanahashi has a problem.
You need an engine of a certain size with a certain degree of compactness, but you want a high-powered engine as well.
Tanahashi needs a small engine to fit in the restricted engine space, but he also needs the power of a large engine because power equals speed. And that isn't all.
The high-pitched sound of Formula One makes you shiver, doesn't it? I really wanted to have that as part of the LFA.
Only a high-revving V10 engine supplies this combination of power and sound, but a traditional V10 is too big for his mid-front configuration. Lexus have made nothing like this before, their production line cars use 6- and 8-cylinder engines engineered for a super quiet ride. This V10 will be the opposite. Tanahashi turns to some old friends for help.
We are a motorcycle manufacturer. We understand power alone is not enough in a vehicle. For a sports car, small and lightweight is critical.
For almost half a century, Yamaha have worked with Toyota to create high-powered, lightweight engines and cars. The legendary 2000 GT, star of the James Bond film You Only Live Twice, and Japan's first true sports car, was the first fruit of their collaboration. Headed by Lexus engine guru Okamoto Takamitsu, the team sets itself an ambitious goal: to create a naturally aspirated V10 engine as compact as a traditional Lexus V8, with the weight of a V6.
I wanted to create something different to any other supercar engine.
Normally, engineers use turbochargers to boost the output of smaller engines to simulate V10 power. But turbocharged engines don't have the rapid response, acceleration or sound of a naturally aspirated V10. By using Yamaha's motorcycle know-how, the lightest metals and redesigning the engine's guts, Okamoto creates a masterpiece of engineering. A non-turbocharged compact V10 that fits into a mid-front design while keeping weight to a minimum. The engine starts life in Toyota's Miyoshi plant as molten aluminium. It's cast in a 3D resin-impregnated sand mold made from 37 individual blocks that take a week to fashion. With the blocks fitted together, the mold is ready to be filled. At 750 degrees Celsius, impurities are scooped off the top of the molten aluminium. The liquid metal flows into the mold as a vacuum sucks out any contaminating gases. Two hours later, with the metal set, the sand is hammered off to reveal the solid aluminium engine block inside. It's off to Toyota City's Honsha factory and the company's highly confidential Formula One engine facility.
These works are always off limits. We're going to go in. Are you ready? Come in.
Television cameras have never been allowed in here before. For a decade, Toyota spent big competing in Formula One racing. But without a win in 139 races, they withdrew in 2009, leaving this state-of-the-art facility idle. For the LFA team, it was too good an opportunity to miss. The close parallels with F1 engine technology make this milling facility a ready-made fit. In these million-dollar automated machining tools, the rough engine casts are milled, drilled and polished before emerging as precisely spec'd engine blocks. Then the robots hand over to humans. In a sealed room, Takumi hone every sharp edge using precision polishing tools. Finally, a highly skilled Takumi pre-assembles the finished engine blocks to check they fit precisely. These blocks and screws are paired for life. Disassembled, they travel as a unit to Yamaha's Iwata city plant, 90 kilometers southeast of Toyota City. The engine room here takes obsession to new heights. As you'd expect, hairnets and airlocks prevent any particle contamination. But the room is also kept at a constant temperature and humidity to ensure that every engine part is at the same state of thermal expansion during assembly. This is more laboratory than workshop. The 2,200 engine parts are divided into 61 different kits for assembly by number. 4 highly trained Takumi work here. Each is responsible for a single engine from start to finish. To avoid any mistakes, they follow a series of on-screen instructions. It takes 2.5 days to complete the build of one engine. Each hand-assembled engine bears the Takumi signature. Before this masterpiece goes anywhere near a car, it undergoes a half-day of exhaustive testing in the room next door to engine assembly. The resulting 4.8-litre engine is so responsive that it takes just half a second to reach 9,000 RPM. That means instant acceleration, whatever gear you're in.
This engine has excellent response and more RPM than any other commercially available engine.
Response time is so fast that a digital rev counter is the only unit able to keep up. And the sound of this high-revving engine is unmistakable.
The sound of the LFA is unique and once heard, never forgotten.
To achieve the engine soundtrack that Tanahashi insists upon requires more of Yamaha's specialist knowledge.
We are a manufacturer of musical instruments, so when it comes to sound technology, we have a certain level of know-how.
Honji Yoshikazu is obsessed with sound.
I think the relationship between a super sports car and its driver is like the relationship between a top musical performer and their instrument. When they play in a certain way, they can listen to that sound and use it to produce another, better sound.
Critically, a car has 2 different sound characteristics.
One sound is the exhaust. You can call it an iconic sound. Just by hearing that sound, you know which car it is. The other, which we were particularly concerned with, is the sound heard by the driver.
To refine the driver's soundtrack, Heiji Maruyama, general manager of Yamaha Motors, had to redesign the component that sits on top of the engine, called the surge tank, by turning convention on its head.
The function of the surge tank is to send air equally into all 10 cylinders. Normally, techniques to reduce noise from the intakes are used. We thought to go the other way and use it to amplify the sound, to communicate it to the driver.
Maruyama tunes the chamber by varying the thickness of the surge tank's upper surface and adding internal vibrating ribs.
The construction is very like that of an acoustic guitar or violin.
The team channeled these good vibrations back into the cabin using sound passages.
We use these to send low-pitch sound to the driver's feet and higher frequency sounds through at ear level.
The driver is in the middle of this dynamic surround sound system. The completed engine is forklifted onto a waiting truck for shipment back to the LFA works. Here, as part of the assembled drivetrain, it's inserted into the cabin's belly, guided only by eye. With the guts of the car in place, it's time to feed them. An automated pump injects engine oil, brake fluid and coolant into the appropriate underbonnet opening. In Japan, machines play a tune to alert anybody nearby that they're running. This one plays an American folk song. With the precise volume of fluid added, the pump stops, as does the music. The car's 9 moulded glass fibre body panels are manufactured off-site. This material is both strong and light, but far cheaper to replace than carbon fibre, should the car crash. The paint shop is under the same roof as assembly, but it's a very different world in here. At the LFA works, paint is one of the few production processes performed by robot. The company believes they give a more consistent finish. But there's always an ongoing human battle in the paint department.
Dust is the greatest enemy for painting. If dust gets into the paint surface, when it's heated, the dust swells up and causes a blister. So the atmosphere is controlled on a daily basis, and there's a strict dress code.
Up to 5 layers of paint are applied. And where robots can't reach, humans can. Job done. The sprayed panels are dried in an oven at 100 degrees Celsius for 50 minutes before being wheeled out for inspection. The battle against dust continues, with water nozzles spraying a fine mist into the air to stop anything drifting onto the pristine surfaces. A bright light inspector spots any blemishes and marks them up to be polished out. The completed panels are wheeled out of paint across the factory floor and attached to the carbon tub back in assembly at the 3rd position on the line, known as final. Here, the hand-stitched leather interior is installed, and the forged aluminium wheels with bespoke Bridgestone tyres are also fitted.
It looks as if the associates are performing each task very slowly, but every one of them is working very carefully and with a high degree of certainty. If you compare it to a sport, they are top players who complete a successful play every time.
The LFA works runs like clockwork, yet there's no clock watching.
The reason why there is so much time is that Chief Yamanaka tells us to take our time and work slowly so that we can make something that we know is good. How can I put it? He says that in order to ensure quality, we can take as much time as we need. That goes for overtime as well. If it means we make something good, then we can do overtime.
The only stipulation is that one car must drive off this assembly line every day. And from the beginning, Chief Engineer Tanahashi was clear that only 500 would be built. At a car a day, that will take just 2 years. And then, this factory will close.
Making only 500 cars positions the LFA as a very special car. There is no plan to make any more at all.
Even pricing the LFA at $375,000, the most expensive Japanese road car ever, a limited production run isn't going to recoup the costs of development, the use of cutting-edge materials, and unlimited overtime.
I think it will be difficult to make a profit with only 500 units delivered. But by producing the LFA, the Lexus brand gains in value and is well received worldwide. I think the legacy will be left in technique, knowledge and teamwork for making cars that will please our customers in the future.
Back in 2004, with the prototype build, Chief Engineer Tanahashi takes a bold decision. He wants the car proved on the severest of tracks. Nothing in Japan fits the bill. So he takes the entire development team to the notorious Nürburgring in Germany.
For us car makers, the Nordschleife on the Nürburgring is like a mecca for cars. This is where this car was honed.
The 20-kilometer Nordschleife section of the Nürburgring is infamous as the world's most punishing test track. For 4 years, the team tests every aspect of the car's engineering around the Nordschleife's dips, jumps, relentless corners, and flat-out straights. The car's development makes progress towards its production deadline, but Tanahashi wants to fast-track its fine-tuning. In 2008, he throws it into the unforgiving world of racing and enters the Nürburgring 24-hour race.
It was purely to get more feedback on the production type LFA and to improve it under real race conditions.
The brutal experiment works. A year later, the revised car wins its class. Tanahashi is finally happy, and in 2010, the LFA goes into full production. And when in 2011, a special race edition of the standard LFA is launched, its name pays homage to the racetrack that forged it.
It is with thanks to that sacred place that we called it the Nürburgring package.
This Nürburgring package has a retuned engine which pumps out 571 horsepower, 11 more than the standard engine. This extra power requires more downforce to keep the car on the track, so the rear spoiler is larger and fixed. And left and right canard fins on the car's front bumper also increase downforce. The stiffer lower suspension makes it more suitable for a life on the track. Finally, to increase acceleration, the computerized transmission is upgraded to change a split second faster. It all adds up to a Japanese supercar. Only 50 will be built, each with a price tag $70,000 more than a standard LFA. Back at the LFA works, in assembly's last position, the wheels are aligned to ensure the car handles perfectly. After 3 days in assembly, the car officially moves to inspection. The inspection process involves 7,000 separate checks. Hayashi Katsumi does the first of 1,482 of these under lights.
Right now, I'm inspecting the paint surface. I'm using my hands to feel for any uneven areas in the bodywork. You have to touch it gently, like I'd touch a woman. I've been doing this job for 30 years. If I didn't have my wife, then it would certainly be my lover.
With the internal and external surface inspection signed off, the car leaves the LFA works for good. It's driven through the Motomachi plant into quality control. This will be its home for the next 7 days. The checks performed here range from speedometer and brake tests to water tightness. The reports fill a 350-page booklet. Finally, test driver Amano Nobuaki ensures each of these cars is road ready when it leaves the factory. The car is bedded in on Motomachi's very own test track. The mass sections of the bodywork are to protect vulnerable areas from stone chips.
I think this is the best possible job in the world.
Amano checks the car's controllability, engine sound, power, braking performance and vibration noise on the 1 kilometer track. There is one danger driving this car every day.
Every now and again, I just want to forget the job and drive this car away somewhere to have for myself.
This car is complete and ready for its owner. To date, all 500 LFAs are spoken for. No more will be sold. The Lexus brand is safe, but Tanahashi still has something more to prove. In 2011, the team reassemble at the Nürburgring to put the car into the record books. They're out to beat the fastest official time by a road-registered production vehicle. This is the chance for the Nürburgring package to prove its pedigree. With test driver Ida Akira behind the wheel, the team held their breath.
I push the car on every corner. There are over 150 corners, driving very aggressively, but at the same time, I enjoyed it.
To beat the record, Ida must average 167 kilometers per hour over the track's 20 kilometers.
I had no concept of the time when I crossed the finish line.
Seven minutes, 14 seconds. The fastest official time by a production car not using slick race tyres. And the 5th fastest time ever.
It was an unbelievable moment. It's one of the best moments of my life. There are a lot of sports cars, but this one gives the driver a really direct experience of driving. This is a very emotive car, a driver's car.
This car could redefine what Lexus means to the world.
We developed the LFA with a new direction, one of emotion, passion and power. This was new to Lexus.
And this mega factory could redefine how all Lexus cars are built.
We took on all kinds of challenges, and there were new production needs. I look forward to seeing the outcome of these, both visible and invisible, in future cars.